here are the last two topics we need to cover for the Unit 5 test. First, fitting a line to data, and then second, predicting with linear models. So the first thing we're going to do with fitting a line to data, our goal is to find an equation that models the data well. Our first step is going to be to plot the data. And I had a table of data and I plotted it nicely on this graph right here. After you've plotted the data, you need to draw a line of best fit. So I'm going to draw this line of best fit and have something like this. Looks pretty good. The next thing you need to do is you need to pick 2 points that are decently far apart. Don't make them too close together, but they have to be something you can estimate pretty accurately. So I'm going to pick a point right there, and let's say right there. And they have to be on the line. They don't necessarily have to be in the data set. So this one looks like about -2 and, I don't know, 1.5. And then this one looks like it's at 1, -2. After you find the points, your goal is to find the equation. So find the equation. And I think I said find when I gave you the words before. But you're going to do that by first finding the slope of the line. Let's call this one x1, y1. And let's call this point x2, y2. So we know we have to do y2 minus y1 over x2 minus x1. So y2 is going to be -2, and y1 is 1.5, over x2, which is 1, minus -2, which is x1. So that's going to be -3.5 over 1. So, oh, not 1, excuse me, 1 minus -2. I just made a mistake that we all make all the time. There's 2 negatives, so it's going to be 1 minus -2, which is 1 plus 2, which is 3. So we could simplify this a little bit. 3.5 over 3, make that a little better. -3.5 is -7 over 2 divided by 3. -7 divided by 3. Dividing by 3 is the same thing as multiplying by the reciprocal, so it's going to be -7 over 2 times 1/3. So we -7 over 6. So the slope of that line is -7 over 6. Now we need to write the equation of the line, and now we have a we have a slope, and we have 2 points, so we might as well use point-slope form, which we know is y minus y1 equals m times x minus x1. I like this point pretty well because there's no fractions in it. So we know that we're going to have y minus -2 equals m, which is -7 over 6, times x minus 1. This y value went right there, and this x value went right there. So if I just wanted the equation of the line and I didn't specify what form it's in, you could just stop right there. If you wanted to convert it to slope-intercept form, you need to isolate y. So you have y plus 2 is equal to -7 over 6 x plus 7 over 6, because that's -7 over 6 times -1. Then subtract 2. So you're going to have y equals -7 over 6x plus 7 over 6 minus 2. We need this to be in sixths, so it's going to be 6 over 6. So we end up with y is equal to -7 over 6x plus 7 over 6 minus 12 over 6. 7 minus 12 is -5, so y is equal to -7 over 6 x minus 5 over 6. And let's see if that makes sense. The slope is -7 over 6, so it's about -1. Looks like the slope is about -1. And then our y-intercept looks like it's about -1, and we got -5, 6. So first plot the data, draw the line, pick 2 points, use it to find the slope. You could use point-slope form and get the equation. So this was in point-slope form right here. And then you could translate it into slope-intercept form if that's what it asks you to do. Or let's say you wanted it to be in clean standard form, which is ax plus by equals c. These are all different forms of the same line. You need x and y to be on the same side, so I'll add 7/6 x. So y plus 7 over 6 x equals -5 over 6. I like clean standard form. I want them to be all fractions. So let's multiply everything by 6. 6y plus 7x is equal to -5. So this would be the clean standard form. 3 forms of the same line. Clean standard form, slope, Slope-Intercept. And then the first one we got was point slope form. Again, if I don't tell you which form, you can stop and point slope, but I might ask you about Slope-Intercept, or I might ask you about clean standard form. The next thing I want to talk about is that second part, making predictions with data. And this is primarily with respect to using a calculator to do a line of best fit. So when you're entering data into your calculator, remember you want to look for L1 and L2. That's under Stat and Edit. If you need to clear the whole list, you go up to L1, hit Clear and Enter, and that'll get rid of it. If you hit Delete, it'll delete the list. If it doesn't say L1 and L2, remember you can use Setup Editor, and that will reset your L1, L2, L3, etc. So after you have all of your data in there, you want to graph it. If you just hit graph, you might not see anything for various reasons. The first reason is plot has to be on. See how it's highlighted? So it's on, but we're not seeing it. So that means we're looking at the wrong part of the graph. You can then go to Zoom, and then go down to 9, which is Zoom Stat. Very helpful zoom. Oh, look, there are all the points. The next thing you want to do is run a linear regression, and you're going to do that. You're going to do that by going into Stat, Calc, LinReg. You might have to press Enter a few times or just once. And it gave me the A value, the B value, and the R squared value. Those are the really, really important things. You want your R squared value to be as close to 1 as you can. The R squared value is a measure of accuracy. The closer to 1, the better the line of best fit. Now, as you remember, we could write these numbers down and then put them into Y1, or you can go to Y equals, go to where you want the function, and then you go to vars, statistics, which is 5, and go over to EQ. And if you run reg EQ, oh, it just puts it there. It's on, so you say graph, and now the line gets graphed. You can now use this function to predict values outside of this data set. So if I wanted to predict something to the right, I mean, we can look at our table and see that our table, the x values just go up to, it looks like it's 76. Let's say we wanted to get it with 100. If you go back to the beginning here, you can actually, instead of just using your calculator with a piece of paper, if you go vars, yvars, function, and y1, and then put parentheses the number you want to evaluate this at, what this is doing is plugging 100 into the function that you have right here, this function. So instead of typing it out and doing it by hand on a piece of paper, you can just say y1 of 100. Again, that's vars, yvars, function, and then y1. So if I do this, it's going to tell me what the function is at 100. There you go. I hope you found this video helpful. Good luck on the Unit 5 test.